All right, let's get right into it. When you think of a detective story, you probably picture foggy streets, maybe a magnifying glass, but the biggest mysteries today, they're being solved inside the ones and zeros of our digital lives. So today, we're opening up the Digital Detective's Casebook to talk about computer forensics.
You know, every single thing we do online, every email we send, every website we visit, even just plugging in a thumb drive, it all leaves a digital footprint. It's like a trail of breadcrumbs. But that leads to the really big question, the one at the heart of all this. What happens when someone deliberately tries to wipe that trail clean?
And that's exactly where digital forensics steps in. Now, this is way more than just recovering a few deleted files. It's a full-blown science. The whole point is to take this mountain of digital data, figure out what really happened, and present the truth in a way that is rock solid, something that can actually hold up in a court of law.
What's so cool is that this super modern field is actually built on an old-school idea from physical crime scenes. It's called Locard's exchange principle, and it basically says that a criminal always leaves something behind and takes something with them. Well, in the digital world, this is true on a whole other level. Every time you open a file or connect to a network, there's an exchange of data. Little bits of digital DNA are swapped.
Now, to follow that trail of digital DNA, investigators can't just go clicking around hoping to find something. Oh no, there's a strict set of rules they have to follow, a whole playbook that makes sure this is a real, disciplined science.
This whole process is called the forensic life cycle. So first you have identification, that's finding anything that could hold evidence, like laptops, phones, you name it. Then comes collection, where you get the devices and, this is key, make a perfect bit-for-bit copy of all the data. Only then, once you have that copy, can you move to analysis, which is the actual detective work. And finally, you have to report your findings in a totally impartial way. It's methodical, step by step.
And sitting on top of that entire process is the one golden rule you can never ever break: integrity. An investigator's #1 job is to preserve the original evidence. You never work on the original hard drive, ever. You work on that verified copy you made to make absolutely sure the digital crime scene is left completely untouched.
So how do you prove you didn't mess with anything? You use something called the chain of custody. Think of it like a logbook that travels with the evidence. It tracks every single person who touched it, when they touched it, and why. If that chain ever gets broken, poof, your evidence could be completely worthless in court.
Okay, so we've got the rules of the road down. Now let's get to the really fun part, the investigation. This is where we start connecting those digital breadcrumbs and seeing what kind of story they tell.
So, let's imagine a classic scenario. An investigator has a USB drive, and they need to prove that this specific drive was plugged into that specific computer to steal some files. How in the world do you prove that? Well, the computer itself actually remembers.
Our first clue is hidden away in the Windows registry. You can think of the registry as the computer's diary or its guest book. Every time a USB drive is plugged in, Windows jots down the make, the model, and, most importantly, the unique serial number of that device. The computer keeps a list of every visitor.
Okay, clue number 2 comes from these little things called LNK files. So when you open a file, Windows often creates a tiny shortcut file for it. And this little file is an absolute goldmine for investigators because it records the original location of the document. So if a file named project_alpha was opened from a USB drive, the LNK file will say so.
And this is where it all comes together so beautifully. An investigator can take the log file that shows when the USB was first connected, combine it with the timestamp from that LNK file showing when the document was accessed, and then add the registry timestamp for when the drive was last seen. Suddenly, you have a precise, minute-by-minute timeline of the entire incident. It's amazing.
But of course, it's a constant cat and mouse game. As fast as forensic techniques get better, so do the methods people use to hide their tracks. And that brings us to the other side of this chess match, anti-forensics.
Anti-forensics is basically anything and everything someone might do to throw an investigation off course. This can be as simple as using a program to wipe data, or as complex as hiding information, using encryption, or even trying to attack the forensic tools themselves. One of the most clever techniques out there is data hiding, also known as steganography.
Let me show you how it works. Just picture a totally normal image file, something you wouldn't look at twice.
Well, steganography is the art of taking a secret message and hiding it right inside the data of that image file. You're not just encrypting the message, you're hiding the fact that the message even exists in the first place.
And here's the brilliant part. To you and me, the image looks exactly the same. There's no visible change at all. This is called perceptual transparency, and it makes the image the perfect digital hiding spot. It's hiding in plain sight.
So what you have is this constant back and forth, this technological arms race between the people trying to find the truth and the people trying to hide it. And believe me, the battlefield is getting way more complicated every single year.
Just look at this comparison. It says it all. Back in the 90s, an investigator was probably looking at one computer with a hard drive measured in megabytes. Today, we're talking multiple devices, phones, tablets, laptops, all connected to terabytes of data in the cloud. And almost everything is encrypted by default. The scale is just staggering.
And it's not just about computers anymore. The modern crime scene is shattered into a million pieces. The key piece of evidence might be on your smartwatch, your smart speaker, your car's navigation system, or your doorbell camera. Rebuilding the story means pulling clues from dozens of different places. Which really leaves us with this one final massive question. In a world where data can disappear, where encryption is everywhere, and where anti-forensic tools get more sophisticated every day, can we always find the digital truth? Or can it sometimes be erased for good? The jury is still out on that one.